Okay, we are working on example 7 on page 2 of module 4, lesson 1, lines and angles. So for angle B, we had just found that because this is a straight line, we can do 180 minus 109 to get the 71. And I was telling you as the video stopped that if you wanted to check it, of course, you could just add those two and it should add to 180, because if two angles make a straight line, they add to 180. And then they want to know what angle C is, and C and B are vertical. And so if B is 71 degrees, so is C. And then I wrote an extra little note there, vertical angles are equal. Usually when you read about them, they'll say congruent. Congruent is just another word for equal. So these two are equal, these two are equal, but they're not all four equal. And everywhere you go around the picture, these two add to 180, these two add to 180, these two add to 180, and these two add to 180. So all the straight angles will add to 180. So you can kind of check it once you're done. We're going to skip example 8 because it's a little bit complicated and it's nothing that you need to know right now. Plus we have 12 pages to get through today. So every time I see someplace that we really don't need it, I'm just going to move on. So let's go ahead and go to our third worksheet from lesson 1. This is plane figures and solids. So module 4, lesson 1, plane figures and solids. And this will be the last one we have in lesson 1. And then we're going to skip lesson 2. We do a little brief thing in lesson 3, and then we'll go on to 4 and 5. So classify each triangle as equilateral. Remember what we said about those earlier? Equilateral, the name tells you all equal sides. So I go 2 are equal, none are equal because there's no tick marks. Oh, all 3 are equal, so we can immediately go here and write equilateral. And again, this worksheet is just to help you with your vocab. So when we start doing perimeter and area and volume, and I say, what's the area of that parallelogram? You know what it is. So this is just familiarizing yourself. Isosceles, we said, had 2 equal sides. If you remember, we drew this picture on the front of the fill in the blank. So that matches with this one. It's just upside down. So isosceles. And then we had this on our fill in the blank. Scalene meant all 3 sides are different, and how we know they're different is there's no tick marks to show that any 2 are equal. So that's how you know they're all different. So that is our scalene. All sides different, 2 sides equal, 3 sides equal. And remember, an equilateral triangle is also isosceles, because the definition of isosceles is at least 2 equal sides, and this one has at least 2 equal sides. But this is not an equilateral. So equilateral is isosceles, but isosceles is an equilateral. Yeah, I know, get away from all that confusing stuff, right? Okay, this is important. This is something that you definitely want to know for future math classes, real life, if you're building stuff, all kinds of uses for this. So on page, I think it was page 4. Nope, page 3 at the bottom, we have a theorem that says the sum, that means when you add the 3 angles of a triangle, angle X plus angle Y plus angle Z, they will always equal 180 degrees. Huge property. That is definitely something you want to remember for later. So the 3 angles of a triangle will always add to 180, or in math terms, sum to 180. So when we see a picture like example 2, I go, well, I have 37 and I have 117. So let's see how much I have so far. 117, 37, so that's 14, carrier 1, 5, it's 154. So that means angle Z, oh, nope, that's an X. Angle X is going to be 180 minus 154. Because if we know the 3 add to 180, take that sum and subtract it out. So that's going to leave us with 180 minus 154. We have to borrow. So that's going to be 26 degrees. So angle X equals 26 degrees. And you can certainly check that. 37, 117, 26. So 14 and 6 is 20. Carry our 2, 3, 4, 5, 6, 7, 8. Boom. You just verified it's correct because the 3 angles have to add to 180. Okay, angle B on the second one. So who remembers how many degrees is that? Right angle, 90 degrees, right? So 90 and 30 is 120. And so we're going to do the exact same thing we did on the last one. 180 minus 120 is 60 degrees. Whoops, on the paper, Norris. So those two add to 120. Then we know the 3 add to 180. So 180 minus 120, 60 degrees. And always put your degrees. When we give a paper pencil test for this, 1 point for every problem is the label, whether it's inches, degrees, miles, so on. Okay, so those are pretty easy, right? So angle A plus angle B plus angle C equals 180 degrees for a triangle. So that would be something I would maybe write there and highlight just to remind yourself, because like I said, you'll see many, many applications of that later. Okay, so fill in each blank. A closed plane figure that has 3 or more line segments is called a closed figure that has 3 or more line segments. Polygon. This is page 3 of your glossary again. So this would be polygon, and notice it does have to be closed, which means you can't have a gap in it. The side opposite the right angle of a right triangle. Ooh, we already did that earlier, right? So what's this side called here? Hypotenuse. And these two sides? Legs. So the two sides that hook onto the right angle, legs. The side opposite the right angle is the hypotenuse. So leg, leg, hypotenuse. So we have hypotenuse. That's a side opposite the right angle. So you can probably guess that's an pretty important vocabulary word if I put it on twice. And it is, because guess what the last thing is we learn in this course? Pythagorean theorem, which deals with right triangles. A squared plus b squared equals c squared. The distance across a sphere passing through the center. Oh, I think I probably can find that picture in here. Circle. So here's a sphere. The radius is the center to a point. The diameter is the distance across passing through the center. So it's just like a circle, right? Except this is 3-dimensional. So from the center to the outer point is the radius. And when you have 2 radii, then you have a diameter. So same exact vocabulary as a circle, except a circle is a plane figure. A sphere is 3-dimensional. So the diameter is the distance across the sphere. passing through the center, just like a diameter is the distance across a circle passing through the center. So they share that vocabulary. 2 radii equals 1 diameter. Or a radius is half of a diameter, however you want to think about it. So the distance across a sphere, all the way across, passing through the center, is the diameter, just like a circle. So that's nice. You don't have to remember any new vocab there. Determine whether each statement is true or false. So we had some of these earlier, so let's see how well you learned. A trapezoid has 4 sides. That's what that's saying. So you know what a trapezoid looks like from our pattern activities, the red pattern that we did back in module 3. So does it have 4 sides? Yes, it does. A scalene is also isosceles. So here's scalene. So if it has 3 unequal sides, can it also have 2 equal sides? No, that's redundant, or not redundant. They're like opposites. No equal sides can't mean 2 equal sides. So basically you just need to know your definitions. No equal sides is not the same thing as 2 equal sides. So that's definitely false. A rhombus is a rectangle. So all I say to myself is, does a rhombus have 4 right angles? Nope. Then absolutely not. Can't be a rectangle. Nothing can be a rectangle or square unless it has 4 right angles. A square is a parallelogram. So I draw my square and I ask myself, does it fit the definition of a parallelogram? Parallelogram, remember the name. Are the opposite sides parallel? Yes and yes. So that's a true statement. It wouldn't be true the other way. A parallelogram looks like this. It's not a square, but a square is a parallelogram because it has opposite sides parallel. Okay, let's go ahead and look at the back page. So identify each regular polygon. So this is, I think it's page 5. Oh, no, it is page 3, where all the names of the polygons are: triangle, 4 sides quad, 5 pentagon, hexagon, 7 heptagon, 8 octagon, 9 nonagon, and 10 is decagon. So this one has 1, 2, 3, 4, 5, 6. So that is a hexagon. And 1, 2, 3, 4, 5. I always remember this one because it looks like a house. So think of a pent house. So it's a pentagon. And 1, 2, 3, 4, 5, 6, 7, 8. That's our stop sign. So a stop sign is 8 is what's an octogenarian? Someone who's 80s. So 8 sides is an octagon. 8 legs is an octopus. So octa means 8. Okay, find the diameter of the circle. Well, we said that 2 radii make a diameter. So if one radius is 5, and just FYI, in case you don't know this, there's a theorem in geometry that says all radii are equal. So if one's 5, every one I draw in this picture is 5, just FYI. So now we can see the diameter is 10. And then your appropriate label would be centimeters, because the diameter is 2 radii, radii plus radii. So this is our radius plus radius is diameter. So maybe we can mark this as D just for you to study later. So 2 radii equal a diameter. Now they're going backwards. If they give us the whole thing, the diameter, then what is a radius? It's half of that. So it would be 18